Let's now have a look at some of our earlier examples wherein these queries and expressions have been used in great length. Coming back to our earlier example of human resources sample, wherein the users have built another altogether different calculation, which includes all the different types of filters and the query, wherein they have used the term filter where they are filtering the employee table wherein the termination date is blank. So wherever the termination date is blank in the employee table, only those records are calculated for counting. So the ask was, how do we identify active members of right now in the database? So to identify the active values, the user, the designer, made sure that all active members do not have termination date, and therefore for all those records which do not have termination date should be summed and clubbed up to get a value of active members. So to get the active employees list, user wrote this DAX expression wherein he is calculating something and naming it as employee count, that is a measure. And the way to fill this employee count is by accessing the employee table and only taking those rows where the termination date is not blank, right? So he identified the blank rows and filtered them out from the employee table, and whatever was left is shown in this active employees output. Similarly, the same thing can be applied to active supply last year. So same period last year for the date. So for the date range, if you consider, you can get it same period last year of all the actives which we've calculated earlier. Similarly, this is interesting. Divide active YOR by variable by active supply. So if you want certain division to take place, you have one formula, one measure, and this is the other measure. So you can use the term divide to measure one over the other. This is the way. Active minus last year's value is this year's variable. Year on year variation. What is an average age? You can do rounding of an average of age and round it to 0 decimal. Average tenure. So these are all average functions. How do you calculate the bad hires? You do the sum of the bad hires for the same period last year. So that's what you get. What is bad hires? Bad hires is hire date minus termination date into -1 to make it positive is greater than 61. Then it is a bad hire. That means anybody who's worked for less than 61 days is a bad hire, right? How do you do the employee count? Only those members in this given period from the max period, only those members are taken which are active and has an employee date. So if you expand this, you get this. Then you have separation, year on year variation. So first, what is separation? Separation is count of employee ID, right? But you filter whose is blank is not blank. So only those active members, right? So is blank. Filter those employees which are not in the termination date. So people who do not have, or who rather has a termination date, only those value is considered ahead. exactly opposite of the active one. When you write the not, it becomes like this. This and active has only one difference, is that the not operator negates the blank termination date clause. So that means it is not blank termination date. That means you have to only consider those active values. This means it is only active values and it get assigned to a counting of this. So those many separations would have happened. Separations last year, that is same period last year, is what you can do. Year on year change, you can divide and find out. Sum of bad hires, you can do sum of bad hires, and so on and so forth. So this is the way you would ideally would have to check all the different kinds of formulas as per your organizational need, making use of certain inbuilt formulas given to you.